Okay, hi, bear with me because I have a lot of information to cover, but for anyone who doesn't know me, my name is Anita, and I consider myself a very spiritual individual. However, I do have a little bit of holy mischief going on within me and my inquisitiveness for exploring what's on the underneath and social justice. Okay, so tonight I was out shoveling the snow and I heard planes going by, and of course we all know what the planes mean. These are incessant, low humming, drone-ish sounding planes, because normally when a plane goes by, we hear it. It comes into our auditory field and then it leaves. Now, I am a writer, so I've been observing life since I can remember. So all those metaphorical statements of I heard a plane off in the distance, because that's precisely what it is. A plane comes into your auditory field and then it leaves and it's gone. These type of planes that I'm referring to are planes that we all know are relentless in our skies, and they go back and forth, and it is that constant low hum, that drone sound of a low-flying plane, and it's just non-stop to the point where I myself find myself getting extremely agitated. So because I know what that sounded, and because I was out shoveling snow, I immediately started getting a headache, and I thought, okay, so we can expect flurries tonight. And of course, many of you know why. But I decided to come in and do a little bit of research and a little bit of digging. And this isn't your average ordinary digging about chemtrails or cloud seeding. This is about the actual science behind it. So for starters, I came inside and I actually asked ChatGPT, what precipitation does it have to be in order for cloud seeding to occur, in order for cloud seeding to produce snow? And this is the answer. There doesn't have to be a specific precipitation for cloud seeding to produce snow, but normally the ideal temperatures for cloud seeding to produce precipitation, or snow rather, would be between -5 and -15. Is anyone noticing that our temperatures have been -4 to -15? It hasn't gone beyond -14, -15. But that would explain why we've had these consecutive days of negative temperatures. And why does it have to be this temperature? Because this is the ideal temperature for ice crystals to form. However, there needs to be supercooled liquid, supercooled water. Supercooled liquid water. The cloud must actually contain droplets that are below freezing. And these droplets are liquid water because they haven't frozen yet, because they don't have ice nuclei. And this is where cloud seeding comes in. Cloud seeding introduces the nuclei, silver iodide, so that it can form ice. Hence the term ice nucleation. So the water droplets in the cloud have to be below freezing, and then if they aren't producing crystals, they introduce silver iodide into this process, into the system, in order for the water to crystallize and produce ice. Third factor involved here, because you need a certain type of cloud. So the 3 types of cloud that are most commonly the best for cloud seeding conditions are these: the orographic clouds, the stratiform clouds, and sometimes even convective clouds. So let's talk about what those are. So basically, orographic precipitation, or snow or rain, is when the cool air is pushed up the side of a mountain and clouds are formed. Basically, it's the moist air that is being forced up one side of a mountain. As it is being lifted up into the atmosphere, it is cooling and condensing, and it usually forms into rain or sometimes snow, depending on the season. Now, this is referred to as the windward side, and what happens on the leeward side, this is the part that doesn't have the wind. Usually it tends to be in a drier climate or less windy, and it appears to be a bit warmer. So you have the windward side of a mountain and the leeward side of a mountain. And dry air is normally found on the leeward side of the mountain, and the windward side of the mountain is usually where the moist air is. And this is why often when you climb a mountain, you will see two different types of vegetation on either side of the mountain. This is basically what they refer to as a rain shadow area. So basically what happens is the cool air, if this were the mountain, comes in, it hits the mountain, it's forced to rise, it cools and condenses, therefore creating cloud formation. These types of clouds are ideal for cloud seeding. That's the side that gets the heavy rain or the snow, whereas the leeward side is in the rain shadow or even snow shadow. Now, stratiform clouds, those are kind of those mid-level flying clouds, and they almost seem like rippled clouds. They are a bunch of tiny little clouds, or they can even be like a tiny layer of cloud, and they are horizontally layered. And these are the ones that we are seeing being used ideally for cloud seeding, because most of us aren't in mountainous regions, although we do have mountains, the escarpment, and then of course there are mountains almost everywhere. But nonetheless, these are the clouds that the plains containing the silver iodide are using to produce rain or snow. And again, they are usually formed because cool air rises and produces moisture, and it cools and it creates cloud formation. And sometimes they often also form when warm air slides over cold air, and then you have these stratiform clouds. They tend to be featureless, and they look like a sea of clouds now. And it almost resembles fog. So it's like when you are at the ocean or you are standing at the top of a mountain and you see a storm incoming and you see that layer of grayish blanket. That's pretty much stratiform cloud. And then we have those beautiful, immense convective clouds, and those are the ones that appear to grow vertically, and they're massive and they seem very unstable, but they're also really beautiful. And those are the ones that you can actually see and you're like, oh my gosh, that's intense. Those clouds are from the cumulonimbus family of clouds, and of course they are ones that we tend to see sometimes in the summer or just even with a lot of precipitation in the air, and they're just so beautiful. They're massive, and I tend to see shapes in those ones all the time. But those ones definitely indicate a very strong upwards current. Okay, so that was a brief little geoscience lesson on clouds. Now, what does this have to do with cloud seeding? Because you can seed a cloud when it is not snowing. You do not need precipitation for them to cloud seed. And if it is snowing heavily, cloud seeding has little to no effect. However, cloud seeding is easier to observe when it is snowing. So if I had to sum this up in one sentence, cloud seeding can produce snow when clouds are cold enough and contain a supercooled liquid water. Next, I'm going to talk about why silver iodide exists and why when I put up a video saying that the snow sounded like glass, you're going to know why.